Hey everyone, this is Jonathan from Chegg Tutors, and this lesson is on ionic bonds. Now, ionic bonds are the complete transfer of valence electrons, which are the electrons on the outermost shell in an atom, and they are the ones involved in bonding. And it's the complete transfer of valence electrons between a metal and a nonmetal. Now, in contrast to covalent bonds, which are the sharing of electrons between nonmetals, this is the transfer. So the metal gives up electrons while the nonmetal gains electrons. It receives the electrons. So we can write it like this. So the metal, nonmetal, gains electrons, and it becomes negatively charged because it gained something that is negative, an electron. And we call this an anion. A negatively charged ion is an anion. Now the metal loses electrons. It transfers it to the nonmetal. I'm just going to use this symbol for electrons. And it becomes positively charged because it lost something that is negative. And we call a positively charged ion a cation. So the reason they do this is because, like every bond, one atom has something that the other one needs, and vice versa. So the metal, by losing an electron, it actually will see that it has now a stable octet, and the nonmetal, by gaining an electron or multiple electrons, then has a stable octet of 8 valence electrons. So they do this instead of sharing, they just transfer it because one needs to lose electrons and the other one needs to gain electrons. So now let's look at the periodic table of elements. So here we have our metals, which will be forming the cations in the ionic bonds by losing electrons and becoming positively charged. And here we have our nonmetals, which will be forming the anions in a ionic bond by gaining electrons and becoming negatively charged. So most of the salts that we look at, which are just ionic compounds between a metal and a nonmetal, consist of group 1 and group 2 metals. But they can be formed from any metal and a nonmetal. So now let's look at a specific example. Sodium chloride. So let's look at the Bohr model of both sodium and chloride. Sodium has 11 electrons, and we'll just draw its nucleus, which is plus 11, and here are the shells of electrons. So the first shell will have 2, the next will have 8, 2, 3, 4, 5, 6, 7, 8. That's 10, and then it has 11, so we'll put 1 on the outermost shell. So you can already see that if it loses this valence electron here, it then goes down a shell and has 8 valence electrons, which is a stable octet. That's the most stable form of an atom. So let's now look at chloride. So chloride has 17 electrons, so it also has 17 protons. So not considering neutrons here, it's because they are a neutral charge. The nucleus is plus 17 due to the 17 protons. Now let's draw its rings, its electron shells. So its first shell will have 2 electrons, 1, 2. Its second shell will have 8, 1, 2, 3, 4, 5, 6, 7, 8. And then to get to 17, we put 7 on the next one. 1, 2, 3, 4, 5, 6, 7. Now in order for chloride to gain a full octet valence shell, which is 8 total valence electrons, it needs to gain 1 electron because it has 7 in the third shell and it wants 8. So in order for both of these atoms, sodium and chloride, to achieve their goals of getting a stable octet, Sodium is just going to say, hey, take this electron, and it goes here. So now chloride gained a negative, something that's negative, so it becomes Cl minus. And sodium just lost an electron, and it becomes plus. Now they both have full valence shells. Sodium's valence shell is now here. Chloride's valence shell also now has 8 valence electrons. So they're both happy. And now, due to the positive and negative charge that are now formed from this ionic bond, these guys are now attracted to each other due to those electrostatic forces between a positive and negative charge because opposites attract. And this is what an ionic bond is. It's an electrostatic attraction between a metal and a nonmetal due to the transfer of electrons. So what are some of the physical properties of an ionic bond? Well, its melting point and boiling point coincide because an ionic bond is very strong. Those electrostatic attractions are very, very strong. So the melting point is going to be high because it's hard to break those attractions between in an ionic bond. So its melting point is high. And the same logic follows for the boiling point. The boiling point is also high because to go from a liquid to a gas, we have to break those electrostatic attractions. And it's hard to do that because they're very strong. Now the conductivity is how well it conducts electricity. Ions, you can imagine, conduct electricity pretty well because they're charged particles. So it is very conductive. So I hope this helped and taught you about ionic bonds. My name's Jonathan and I'm on Chegg Tutors.